Hello, welcome back. Proof by induction. Again, more exam questions and possible revision for mocks and A-level exams. Further maths. So let's get on and do the math. Prove by mathematical induction that for all values of n, we have this situation for 6 marks. So, how do we get started? Let's go. Well, we have our basis, our 4-step procedure by proof by mathematical induction. Basis, assumption, induction, conclusion. I repeat, basis, assumption, induction, and then conclusion. The basis is here. I'm going to substitute n is equal to 1. Basis subst. If I substitute n is equal to 1, what do I get? It's fairly straightforward. I get, and I right here, and n equals 1 and r equals 1, of course. And I'm just going to write out the question. It's pretty boring, but this is how we do. 2r minus 1 over 2r plus 1 is equal to, and what they give you is n over 2n plus 1. So, there we have it. Now, if I substitute the value of 1, so I'm going to write it out, and I substitute 1, r equals 1, and again I'm going to write out the question, 2r minus 1, have to do this several times, and 2r plus 1 is equal to, well, what do I have? I have 1 over 1 times 3, which is equal to a third. And that's consistent with what we have here, because that will give me 1 over 2 times 1 plus 1. Therefore, I can say works for n equal 1. Because this bit here is consistent with this bit here if I substitute the value of 1. So we get a third both ways. So that's my basis. Now, what about if we need to find out if it will work for k as an integer. So the assumption, we're going to assume that it works for assumption n is equal to k, where k is an integer. So k is an integer. So again here I'm going to write it out, and I put the value of k, and r is equal to 1, and again write out the question. R is equal to 1, and it's very procedural. I again 2r minus 1, 2r minus 1, 2r plus 1, and that is equal to k over 2k plus 1. K over 2k plus 1. I'm just substituting the value of k for n there, and that's it. Now I'll go to the induction part, and of course where n is equal to k plus 1. So the induction, n is equal to k plus 1. It's still part of our assumption, of course. We're still holding that this can be true, but now I'm going to write out k plus 1, and r equals 1 here. Again, more procedural steps. This is what we do each time for the examiner. 2r minus 1 over 2r plus 1. And that's equal to, now I have my assumption, k, and yep, I've got to get this right, k over, and r is equal to 1, and then I write out the question, again, which is 1 over 2r minus 1 to r plus 1. And now I'm going to add the k plus 1. K plus 1 and over r equals k plus 1. And what does that give us? Well, again, I'm going to write out 2r minus 1 to r plus 1. And then move on. Let's extend the page, and we're going to now organize a little bit. So we've got k over 2k plus 1. So that gives us k over 2k plus 1, which is my assumption, k over 2k plus 1, plus, and now here we go, we have 1 over 2r minus 1, which is now 2, and then brackets, I should put everything in brackets, so 2, and then of course k plus 1. I'm going to substitute k plus 1 for r, and then minus 1, close brackets, and again multiplied by, let's extend that, and 2r plus 1, and of course r is again k plus 1, so 2 k plus 1, whoops, one moment, apologies, all in real time, just got to move that, k plus 1, and then plus 1, and close brackets. And yes, let's tidy up. So we've got k over 2k plus 1, plus, and now we tidy up this bit here. That gives us 2k plus 1. Yeah, 2k plus 2 minus 1 is 1 over 2k plus 1, because we've got 2k plus 2 minus 1, 2k plus 1, and over again 2k plus 2 plus 1, so that's 2k plus 3. Okay, we're getting there. Bit of work for 6 marks. We've got to do some work. Now, this is algebraic fractions, and of course we're going to multiply by 2k plus 3, isn't it? Because we've got 2k plus 1 in our denominators, so I've got k times 2k plus 3 over 2k plus 1, 2k plus 3, 2k plus 1 and 2k plus 3, can't escape that. Just your algebraic fractions, and of course again on the same side we've got plus 1 over 2k plus 1, again 2k plus 3, and this will give us, well, that gives us 2k squared plus 3k plus 1, so this gives us on our numerator 2k squared plus 3k plus 1 over 2k plus 1 and 2k plus 3. Now the numerator factorizes nicely. Look at it, that's very nice. The numerator factorizes into 2k plus 1, k plus 1. So 2k plus 1 and k plus 1. That's nice, because that way we can cancel the 2k's plus 1. 2k plus 1 in the denominator, and we got 2k plus 3. So this cancels with this, leaving us k plus 1 over 2k plus 3. We can put it in brackets if you want. No need. So the conclusion then, we could write that out, because the 2k plus 3, we want k plus 1 plus 1. We could do that, because this is identical and equal to What am I talking about? Probably someone saying, what's he talking about? We could write it in a different way. We could leave it as k plus 1 over 2k plus 3, same thing, but sometimes the examiner likes when you can separate it into k plus 1 plus 1, and we can leave it like that. Now, our conclusion is that as the general result has been shown to be true for conclusion, it's true, that's the general result, true for n was equal to 1, and true for n is equal to k, true, I don't need to write true again, do I? True for n is equal to 1, and then I can just write n is equal to k, and finally n is equal to k plus 1. N is equal to k plus 1. Therefore, true for all, and now this is in the question. We go back to the question, and it says true for n is the set of all natural numbers. So we can write it like that. Here we go. There we go. And I'm over time. 11 minutes, a bit too long, but there you go for 6 marks.